Hi, this is Professor Cummings, and this is still Module 5, and we're going over the DMAIC process, and now we are on the analyze stage of the DMAIC process. So I wanted to go over what that means, what you should expect in it, and how you basically implement it. So let's see, the analyze stage. Basically, the technical definition is pinpoint the key input and output variables tied to the project goals. Another way of putting it, in my own words, probably a better way of putting it is, you're trying to make sense of the data and use that data to help direct your efforts. The initial state of a process, the initial implementation of a process can be pretty chaotic and hard to get your arms around. So that's why you go through this whole DMAIC process, to help you get your arms around what this process is and what all the inputs, the outputs are. And I'll go through some of the tools that we use to get to that point. So to know what the analyze stage is, or to put it more into context, you got to know where it comes after in the DMAIC process. And by the name DMAIC, you can figure that out. It comes after the define stage as well as the measure stage. So the problem's already been defined. You've established what the current state is. You've gone through the measurement stage. And, after the process has been established and it's been quantified. So now you're looking at a lot of the data that actually makes this process what it is. All right. And so you've both established, what the problem is. So you know what problem you're trying to go after. You've developed a charter. You've got your cross-functional team. And you've collected the data to understand it. Now, what do you use to collect the data? Your value stream map. So this was one of the best reasons of collecting that value stream map. It helps you lay out that process so you can see what's going on, all of the details that go on within the process, as well as any type of time. So this is the beginning of establishing the data in your data-driven situation, your data-driven solution. All right. So, the define and measure stages, you've established basically the boundary conditions. You know what everything is. You've got numbers assigned to it. You know what everything is doing and why it's there. You've got the takt time, the amount of uptime, any delays, and any type of waste you should have been able to look at from your initial Gemba walk. So a lot of the data that you're collecting is going to come in two forms. One is going to be qualitative data. Basically things like what is and isn't, go, no go, just establishing clear variables in the process. And then there is quantitative data, things you actually measure, things you can actually put numbers to, chart and graph, and you do sort of a statistical analysis on. So again, the analyze stage, takes that data and uses tools to eliminate a lot of the white noise to address the actual problem. Now, we've gone through some of these in other modules, but now I'm going to show you specifically how they apply to the analyze stage. So you're trying to address the actual problem and you're trying to eliminate a lot of the noise. Now, a really good example of a tool that does this, if you remember the Pareto diagram. So doing a Pareto analysis, you're looking at the significant few versus the insignificant many. This is where we get the concept of the 80-20 rule or the 80-20 principle. One of the beauties of this type of a diagram is that it's easy to understand. You can look at things very, very quickly and you can get a very good assessment of what is the problem, where it's focusing, and where you can make your plan of attack. So this is, again, still in the analyze stage. You can't have that approach without having gone through the define and measure stage. So that's where you get this data and you're able to select these tools to utilize them. Now, let's see, this is also a point where you're going to want to get some of the technical expertise involved. Now, they've been involved since the beginning. You needed them when you did your Gemba walk, when you set your value stream map. But one thing that becomes really important, as you've seen in some of your case studies up to this point, is that the technical expertise really helps you with these other tools, things like the Ishikawa diagram or fishbone diagram, being able to understand what is influencing what and when that influence is actually taking place and the magnitude at which it happens. Another example, again, from a case study is the CPOC diagram. It actually literally establishes the inputs, the outputs, the customers, and the process and the suppliers. So again, this is just another way of taking that data, being able to consolidate it, and being able to actually tell a story with that data, help you make sense of what you're collecting. Now, again, along with the qualitative tools or the quantitative tools, now this is where your statistical tools start to come in. We've discussed it, and this has been in some of your readings as well as in some of your case studies. So one of the benefits of statistical tools is they start to show you significance. They show you things with respect to time. They show you when data shifts. You're able to see what the mean is, what is most likely to happen, so probabilities. Another real good point of these tools, if you've ever been familiar with them, I don't know if you got a background in QA, is it helps to eliminate things like biases, which can also help reduce things such as firefighting. Now here's a control chart or a run chart where it actually shows a process, and then it shows this shift. The data line crosses the median, and so 2 runs. Something there, depending on if you have that expertise in the process, you can eliminate or understand why such a dramatic shift can take place. This is the power of having somebody with the expertise or one of the process owners in place. It's also include things such as hypothesis testing, ANOVA, or analysis of variance, looking at histograms, another statistical tool, run charts, and box plots. All of those things help you actually make more sense of the data, understand what the real problem is, and be able to quantify it. You don't know how big the problem is, the magnitude of that problem. So kind of closing this section out, the analyze stage, again, you're making sense of the data and directing your efforts. That's probably the best summary I can give you in the short term. You use the data to eliminate your biases, eliminate white noise, the distractions that don't make sense, don't really have anything to do with anything, determine, what's actually influencing the problem. Any type of weird consistencies you might find, any sort of weird things that show up in a particular period of time, help you get to the root cause. Again, like I said, establishes the root cause. So that is the end of this particular segment, of Module 5. So next we'll be going over the next stage of the DMAIC process, and that'll be the improvement stage.